Hello, this is the EE542 Lab2 summer recording by Henry Chen. This lab is mainly about using AWS, Amazon AWS to set up the similar internet configuration like what we did in Lab 1. So the first part is the AWS setup part. So first you need to create a VPC for virtual private cloud. This gives you a environment for the network configuration. So just need to follow the steps and set up a VPC. So after setting up the VPC, I did set up 4 subnets for the project. So the first two is the client public and server public. This is for client and server to visit the public internet. And second two is the uh, local subnets. This is for the local communication. Uh, there was a topology in the several after this slide. So next part is the gateway setting. The gateway is actually where your VPC communicate with the is the gateway you communicate with the public IP. So just to attach the VPC with this gateway. The next part is the route table. The route table is really you need to add a 0.0.0.0 for the gateway and I use 10.0.0.0/16 for the local communication. It's just two route table. So the next part is queuing for a elastic IP. As I have 3 elastic IPs. So this elastic IP is actually public IP that Amazon provides. So this elastic IP is the IP address that you use to access the public internet. Uh, in the next part, you need to allocate the elastic IP address uh, uh, with your subnets, so so that it can give the router, the client and server machine, the access to visit. So next part is setting up the instance. I set up 3 instances. 2 of them are server and client running but on the Ubuntu system, and the router is like the Lab 1 is keep using the VIO system. So as you can see that the assigned the elastic IP, I think it's the client elastic IP, server elastic IP, and router elastic IP to the corresponding instance. So after you've successfully associate the elastic IP, it will show your elastic IP on the public IPv4 IP, I think. So here is the IP route, the topology. As you can see, router has the 10.0.4.0/24 and 10.0.3.0/24. These two subnets. A server owns the 10.0.4.0 and 10.0.2.0, these two subnets. So for the internal communication, the server can communicate with router via these subnets, and use this subnet, a server can have the public internet access. And similarly to router and client, one is for the local communication and one is for the public. So here is using the trace route to route the IP, like dot two is the the server want to visit client, like 10.3.173, it will has the it can go to the dot 4 to visit the router, and then router go to dot 3. Similarly here, if like the dot 1 is client want to visit server, which is dot 4, so it's like go to the router using this IP, and the router go to the server using this subnet. So next part is some measurement with iperf instruction. iperf instruction is like widely used for package delivery. It supports both UDP and TCP, and in the measurement, it also contains two protocols. At first, like it's just normal UDP transmission. As you can see, the bit rate is about 1 millibits per second, and there are 14 datagrams. And for the receiver, the server part, you can see that the lost percentage is 0. It means all delivered. So in TCP, like the bandwidth is higher, is at 1.02 gigabits per second. So next part, they delay 100 milliseconds to the communication, and then you can see that the first 1 second, because like first 100 milliseconds delayed, so it does not have any communication. So that you can see the bitrate is little lower than the normal bitrate. It's only 787 kilobits per second, and only 11 datagrams was delivered. But after the first second, it reacts normally. And for the TCP part is similarly, the bandwidth drops significantly for the first second interval, and the transfer bytes is like much smaller than the other time period. So that's what the delay 100 millisecond does. And next part, like I set the delay time to 0 millisecond, but it has 10% loss. So you can see the bitrate became normal, but like the package loss rate became 11%, which is approximately 10% though. So as for each time period, you can see it sometimes has 0% loss, packet loss. Sometimes it can go up to 21% packet loss. So actually, it's just giving you an average packet loss to be about 10%. Similarly, in TCP, it does not have like each package, because like TCP guarantee the delivery, but it just need to send several times if like package was lost. So you can see a significant drop. Like sometimes it drop to 501 kilobits, but other times it's all in like megabits. It shows like the some package will deliver multiple times. And this is some kernel check when you doing those deliveries, package deliveries. And the last part I think is using the TBF. TBF is kind of using a buffer, uh, a filter, yeah, a filter, like to have some the filtering rate to be 100 megabits. So for UDP, I did not see a lot of change for that. But in TCP, by using TCP, like you can see the bandwidth is significantly dropped. So it's what I found in this lab. So next part is answering the lab questions. So first question is, how is Amazon able to convert to your public IP and reach your private IP on the interface? So actually Amazon is using a network address translation gateway, so the NAT gateway, the gateway that we calibrate in the first part. So that gateway allows Amazon to convert your public IP and reach your private IP. Question 2, what does disable source desk check setting do? So disabling this thing allows the communication between the client and server go through the router, so the router can see actually what the package is delivered. Third question is why SSH goes down if like IP is changed on the interface. So actually SSH is directly is kind of like a routing path, and once the IP is changed, it means like the origin route does not work anymore. So like the SSH need to have a redirection to your new IP. So next question is what can be used in Vios VM to start DH client in Vios virtual machine. So DH client is using actually the client DHCP. So you just use sudo DH client Ethernet 0 or like any interface you are using that you want to DHCP your client. The next section is a VM are not able to contact internet. Why is that? So if rebooting anything doesn't work, it probably because like your DNS uh, of your virtual machine does not correctly be configured. To fix it, like you can go to this file, use sudo nano to visit this file and override the DNS namer server, probably like using the Google 8.8.8.8. It probably can give you a access to contact the internet. The next question is what does sudo apt update do? So this instruction will update all your installed packages in your system. So it's actually have your up-to-date information of all your installed packages. For those you do not install, you have to install differently. Not you. This does not give you a uninstalled packages. The next question is what's the max throughput and bandwidth you were able to achieve? Why, if there is any difference in measurement between these two readings over the same link? So max throughput, as I showed before, is like 1.00 megabits per second by using UDP. And max bandwidth is like 1.02 gigabits per second by using TCP. I think the the biggest reason is that UDP needs to check every packet, so it has a lot of packets to deliver. But like TCP only needs to check if like this establishment has been, the communication has successfully been established. It does not check anymore, so that it has a higher bandwidth though. So after sudo add 100 milliseconds, is there any change? Yes, there is some change. So as I said in the first 100 millisecond, the system will not going to send or receive any package. So the first 1 second time period, it will have a drop. So after using the TBF, what's your observation and why is it significant above the communication and how it effectively performs performance? So actually, it does not affect UDP a lot because it has a significantly change drop when using TCP. The command rates will limit the transmission rate to 100 megabits per second. I think it probably limits the TCP to send the acknowledgement. Um, the next question is after entering this speeds 10, uh, instruction. Did you get any errors, and why there is no allowed in AWS? So AWS does not allow this command because this command will upgrade the speed of the interface to 10 megabits per second. So this action will actually cause a lot of data flows in AWS. So to limit or like to limit the data pressure, the AWS does not allow you to do this, to enter this command. So last question is like, do the same step on whiles um, on the interface not mapped to the elastic IP? We're able to still get some same observations. It is. So like if like you unmap the elastic IP, actually the VM is the the VM does not have like the access to the public IP, but like the client and servers can still like communicate directly from the via the router. So like it does not affect, actually it does not affect the communication between, because they're the 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 subnets, the internal subnets, it still exist. And yeah, that's the last question.